Good evening, students. Kushi sir again, back with some extremely important topic today. Okay, all of you must have studied SHM. The topic's name is SHM, but with a specification here, that is reference circle. Use of reference circle in solving various seemingly difficult questions in SHM. Especially when the SHM is in a straight line, these reference circles, they play a very useful role. They make the problems easier to solve. Okay, anyway, these are my credentials. Go through. I think you must have remembered by now. Okay. So you always must be knowing that the projection of a particle moving in a circular path with uniform speed, we call that uniform circular motion. That projection of a particle onto any diameter, the projection of a particle moving in a uniform circular motion onto any diameter of the circle, that projection moves in simple Hertz motion along the diameter. If the particle moves in a circular path, its projection onto a diameter moves in a simple harmonic motion, SHM. Circular path means it should move uniform circular motion. Remember this, speed must be constant. Okay. That means, in other words, if a particle moves in an SHM in a straight line from 0 to 0 velocity, the particle can be considered to be the projection of another particle moving with uniform speed on a circular path. Okay. So that one diameter of which is the straight line on which the SHM particle is traveling. That's obvious. This circle is known as the reference circle of the linear SHM of the SHM particle. SHM particle moving in SHM. अब हम दिखाते हैं भाई उसका दैट रेफरेंस सर्कल. देखो ये जो है एक पार्टिकल particle is P dash moving in a circular path in UCM. In uniform circular motion, speed v is constant, and I take a diameter, let's say this vertical diameter M O N. O is the center of the circle. We take it as the diameter. You can choose any diameter, and to the diameter at a perpendicular at O, which looks horizontal in this diagram, I call this some angular position, some arbitrary angular position, phi is equal to 0. Okay. I put a screen here. Along MON diameter, I put a screen and pass parallel light perpendicular to screen from both directions. And let the particle P dash move on the circular path with uniform speed. So, uska shadow, the projection, the shadow will fall on the screen. The shadow will, as the particle goes from here to here, shadow goes from here to here. As the particle goes from here to here, shadow comes from here to here. Shadow moves on the straight line. So as the P dash goes from here to here, shadow goes from here to here. As P dash comes to N position, shadow comes from P to this position to N position along the diameter. As the P dash means the UCM particle goes to this position, shadow also goes from N to O position. So as it completes one revolution, the shadow completes one complete oscillation. This is what we are observing. So that's whole thing I have written here. With a circle of radius A, we can construct a circle with O as the center. We move the particle P dash on that circular path with a uniform speed. We place a screen on one of the diameter. MON is the diameter. We pass parallel like perpendicular string. Whatever I just told you, I have written there in words so that in case you want to read it also, you can read and understand clearly. Shadow means the projection of the particle. P dash falls on the screen. Let the shadow be denoted as P. Shadow is P, as you see. A red letter. That P point is the red point. That the P, and P is actually the particle, that is the shadow which is moving in SHM. Where P dash, the particle is moving in a circular path, that is moving in UCM. Where P moves along the diameter MON in oscillatory manner. This oscillatory motion is known as simple harmonic motion. And the circle is known as reference circle. Figure आपने अभी देखा. Okay. As I told you, I have drawn this line. Phi is 0. That is arbitrarily choosing at the angular position of the particle. With respect to this phi is equal to 0 line will be phi. Phi will be measured from this horizontal dotted line. That is arbitrarily I chosen phi is 0. And that line is perpendicular to the diameter. Okay. So at t is equal to 0, initially the particle P dash is at this location. I saw t is equal to 0. Okay. So this projection will give you the initial position of the SHM particle P. That I have not shown. Okay. And after time t, it is coming from here to here. So this angle, since angular velocity of this position vector is constant, because the speed is constant, so omega t is the angle subtended from here to here. Already it has a initial angular position from phi is equal to 0 line, what an angle phi. So total angle with this phi is equal to 0 line is omega t plus phi. So its projection from the P dash to the diameter is OP. That will be OP sine omega t plus phi. That's what you can see. So they are any time t, the angle made by the OP dash with phi is equal to 0 line is omega t plus phi. So y is equal to, y means which is y? This O is y is equal to 0 and y is measured along this vertical diameter. So at this, when P dash is here at any arbitrary time t, let me write time t is equal to t. This position. So that time the position of the shadow is P. So this is the displacement of the shadow from the mean position OP. That call that as y. This is the y. Okay. So that you should not get confused. So y is equal to how much? See the diagram. Y is equal to, this is thus here the same y. If I draw the perpendicular, that is a sine omega t plus phi. A is the radius of the circle. Okay. So that's what. So y is equal to a sine omega t plus phi. Y is equal to OP. See the picture. Correct. Then take the, if y is the position of the particle, and position of the SHM, position of the P, that is the shadow or SHM body from O. O is y is equal to 0. So what is the velocity along that diameter? Dy by dt, of course. That is velocity of P, that is v is equal to a omega. Let's take derivative. The acceleration, one more derivative of P. I'm talking about acceleration of P, not P dash. P dash is the UCM body. Acceleration of P is a is minus omega square a sine omega t plus phi. But a sine omega t plus phi is your y. So minus omega square y. A is the radius of the reference circle. And as you can see, it is the radius of the reference circle, and that is the maximum displacement of the shadow from mean position to that maximum position is M position. So it is known as amplitude. So amplitude is from the mean position to zero velocity position. So that is also equal to radius of the circle, that is A. So amplitude is also A. I'm just giving, before I go to application of the reference circle, I'm giving you whatever you might be knowing already. So A is the radius of the reference circle, is also known as the amplitude of SHM body SN body, what is that? SHM body P. So from equation 3, you can write, take it to left hand side, d square a by dt square plus omega square y is 0. This is the equation of SHM about the mean position y is equal to 0. Y is equal to 0 अगर mean position है तो ये है उसका SHM equation of the particle moving in SHM. If d square by dt square plus c1 is y is given, so comparing, I say c1, this must be SHM where c1 is must be a positive constant, because omega square is the c1, means c1 must be positive constant. So c1 root over will give you omega. This equation of SHM about y is equal to 0. Just compare here. Just compare here what I have written. So it is about y is equal to 0, and this is also SHM, but with omega is c1 root over. Angular frequency omega c1, it is equation angular frequency. Let me write it. I think I have to be a bit more specific here. With angular frequency c1 root over. Better write that way, है ना? At the mean position, what will be acceleration? The mean position means when y is 0, so his acceleration is 0. The mean position y is 0, so acceleration 0 at mean position. That's what you are observing this, and you must be knowing this also. If d square y by dt square plus c1y is equal to non-zero constant, c1 is positive constant, c2 can be either positive or negative. It is the equation of SHM about the, again, the mean position. What is the mean position? D square by dt square put 0 as the mean position, so y mean is c2 by c1. Okay, so about y mean, that is y mean is about y is equal to c2 by c1. It will move in a oscillatory manner, which is also SHM. Because if it is SHM about a point y is equal to c2 by c1, so it is SHM only. That's it. Nothing to be confused about. Therefore, the equation of the motion of particle is given as d square by dt square plus c1I is equal to c2. c2 is a positive constant. Equation of motion of a particle if the equation, I wrote some thing, just say, I am writing here, if the equation of the particle, motion of the particle is given as d square by dt square plus c1y is equal to c2, as c1 is the positive constant, the solution will give that like this. About mean position, it will be moving in SHM. So mean position is c2 by c1 plus a sine c1 root over is omega t plus some phi. People write plus or minus. I don't have to write because sine itself take care of this. Sometimes it can be plus, sometimes minus. Okay. So this is the equation of SHM about a mean position c2 by c1. If right hand side c2 is 0, then y is equal to simply 0 plus this, or a is a sine c1 root over t plus phi. Omega is how much? C1 root over. c2 by c1 is what? Y mean. A is what? Amplitude. Phi is what? Phase. From this equation, you know the c2 by c1 value. If this equation is given, then you know two things, two values, y mean as well as omega. But you do not know amplitude or phase. So this omega is what? Angular velocity of the particle moving in UCM. But in case of the SHM particle, we don't call it angular velocity, we call that angular frequency. That's what I wrote here. So A and phi, how to know that? That will be known. You need to know some other information like boundary condition. What is the velocity at time this time, or acceleration this time? That boundary condition, initial conditions have to be specified if A and phi have to be determined. Two boundary conditions required because two constants, A and phi, two unknowns. So what is the usefulness of the reference circle? We can solve the linear SHM problems in a graphical way by drawing the reference circle for an SHM body in a very easy manner. We can solve, especially the distance. किस टाइप का क्वेश्चन हम सॉल्व कर सकते हैं यूजिंग रेफरेंस सर्कल? किस टाइप के क्वेश्चन? एनालिटिकल मेथड में कर ही सकते हैं. Especially the distance traveled by SHM body or the distance between two SHM bodies traveling along the same line, the maximum value of the distance or separation between them. इस टाइप के क्वेश्चन यूजिंग रेफरेंस सर्कल आप बहुत इजीली कर सकते हैं, ठीक है ना। अभी विल इलस्ट्रेट दिस नेक्स्ट पेज गिविंग सम एग्जांपल्स। ये समझ में आ गया रेफरेंस सर्कल कैसे बनाते हैं, देख लो एक बार फिर जाके, है ना। एग्जाम में आ जाएगा तो इस टाइप का क्वेश्चन फटाफट हो जाएगा, 1 मिनट के अंदर हो जाएगा, मैं बता दे रहा हूं, ठीक है ना। कोई प्रॉब्लम तो नहीं है। चलो आगे बढ़ते हैं, नेक्स्ट पेज में जाएंगे, कोई नहीं, ठीक। अभी हम नेक्स्ट पेज 2 में जाएंगे, एप्लीकेशन देखेंगे। अभी डिस्टेंस ट्रैवल का एक एग्जांपल दे रहा हूं। ए पार्टिकल मूव्स simple harmonically on a straight line whose equation is given by this: y is equal to 10 sin pi t by 2 plus pi by 6. pi by 6 नहीं है, ये pi by, मैं कुछ गलत दिया, pi by 3 कर देता हूं, ठीक है, pi by 3 उसमें इन सेंटीमीटर में। तो ये क्या है, a is the amplitude 10 centimeter. Omega is how much, pi by 2 is c1 root over, actually c1 root over pi by 2. Omega is pi by 2 per second, radian per second. t टाइम पीरियड कितना होगा, 2 pi by omega, that is 4 second. और फेज क्या है, इनिशियल फेज pi by 3 60 डिग्री, उसको ड्रॉ करते हैं। रेफरेंस सर्कल ड्रॉ किया विथ एम्पलीट्यूड a is equal to, that is equal to your a, 10 सेंटीमीटर लेके मैं ड्रॉ कर दिया एक रेफरेंस सर्कल। बस पार्टिकल जो p डैश था वो ऐसे घूम रहा, कितना एंगुलर वेलोसिटी, पाई बाई 2 रेडियन पर सेकेंड में। ओके, कर लेता हूं थोड़ा सा, ओके। ओमेगा इज पाई बाई 2, इनिशियल पोजीशन कहां पर था, t is 0, it is 10 sin pi by 3, that means it is here, phase is pi by 3, this phase is 0 line, this one is initial position, t is equal to 0 में था। देन ये कौन, एक्चुअली ये नहीं था, बिल्कुल नहीं था, खाली इस ए पार्टिकल मूविंग इन दिस, दैट रेड पार्टिकल मूविंग इन एसएचए वही था। उसका मैं एक रेफरेंस सर्कल बना रहा हूं टू गेट द यूसीएम बॉडी। सो यूसीएम बॉडी पोजीशन नहीं था, 60 डिग्री फेज। तो मैं बोलता हूं फाइंड द डिस्टेंस ट्रेवल्ड बाय द पार्टिकल इन फर्स्ट 11 सेकंड ऑफ इट्स मोशन, स्टार्टिंग फ्रॉम t इक्वल टू t इक्वल टू 11 में कितना डिस्टेंस वो ट्रेवल किया, t इक्वल 0 सेकंड टू t इक्वल टू 11 सेकंड। देखते हैं उसका फेज क्या है भाई, पाई बाई 3। If phase is equal in this form, n into pi by 2, where n equals 0, 1, 2, 3, that means phase is equal to 0, pi by 2, pi, 3 pi by 2, 2 pi, 2.5 pi. Yes, form में है, starting point here, 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 or here, or here, ये चारों पॉइंट का स्टार्टिंग पॉइंट है। Then I'll the distance traveled by the SHM particle will be equal to the amplitude in each time interval of t by 4 from the starting time. अगर इधर से शुरू कर रहा है वो फाई अगर पाई 0 है या पाई बाई 2 है या पाई है या 3 पाई बाई 2 या 2 पाई है, तो अगर यहाँ से शुरू किया तो आफ्टर, दैट मीन्स SHM body is here, UCM body is here. After t by 4 time, this will be here, SHM UCM body will be here. The black and dark red, they will be same point. So the distance traveled by the SHM body is amplitude. I am not bothered about distance traveled by the circulating body. Okay, I am not asking about distance traveled by the UCM body. That doesn't exist, UCM body. So the only SHM body is there. Now to solve it easily, I'm drawing the reference circle. Okay, so this is nothing but the reference circle. Reference circle. Okay, this is the imaginary UCM particle, that P dash. Okay, ओके तो जैसे रेफरेंस हम ड्रॉ कर दिए, तो ये फेज अगर ऐसा है, पाई 0, पाई बाई 2, पाई 2 पाई पाई 3 पाई बाई 2, तो हम एक जो बेसिक मिनिमम टाइम स्पान को T/4 लेंगे और देखेंगे कितने क्वार्टर टाइम पीरियड है वो गिवन टाइम में. ओके, देन विल कैलकुलेट द डिस्टेंस. अगर phi इज नॉट इन द फॉर्म ऑफ n इंटू पाई बाई 2, जैसा कि ये पाई बाई 3 दिया हुआ, इट इज नॉट इन दिस फॉर्म, है ना. तो डिस्टेंस ट्रेवल एसएचएम पार्टिकल हम इधर से क्वार्टर टाइम पीरियड में डिस्टेंस ट्रेवल विल नॉट बी ए, बट हाफ टाइम पीरियड में डिस्टेंस ट्रेवल विल बी डेफिनेटली 2a. तो इधर जाएगा, इधर जाएगा, इधर तक आएगा. Since it is a half time period, so this small distance is the same. So that means this distance travel is equal to the diameter of this. So it is 2a. Okay, that's what I written. If phi is not equal n pi by 2, so the minimum time span को आप T/4 मत लीजिए. Don't take T/4, take T/2, so that the distance traveled by the SHM pile is 2a. तो हमको क्या दिया हुआ, 5 pi by 3 में दिया हुआ, तो it's not in the form of n pi by 2, so I'll take T half time period as my minimum time span. So every half time period, it particle travels 2a distance. So we take T/2 minimum time span for calculating the distance. So T/2 is 2 seconds. Because t is 4 seconds, already in the beginning I told you, because pi by 2 is the omega, so 2 pi by 2 is 4 seconds, but T/2 will be 2 seconds. So every 2 second interval, it will travel a distance of 2a. That means in 11 seconds, how many half time periods are there? 5. There are 5 half time periods, each half time 2. So less in 11 seconds, how many half time periods will be there? You can see 2, 11 by 2 is 5.5, only 5 full half time periods. 1, 2, 3, 4, 5. 5 half time periods over. 10 seconds over. After that, one more second. 1 more second means 1 quarter circle. That part we will discuss. So, but up to 10 seconds, full 5 half time periods. Okay. So, how much what distance travel? Each half time period travels to a distance. So, 5 half time periods, 5 into 2, 10 a distance, 10 into 10, 100 centimeter. So, 0 to time t is equal to 0 to t is equal to 10 seconds, just travel 100 centimeter. Then last 1 second. Last 1 second आ जाओ फिर डायग्राम में, कितना इजी है. यहां से यहां तक यूसीएम पार्टिकल जाएगा, उसका प्रोजेक्शन डी से एन को आएगा पहले. आफ्टर दैट इट गो फ्रॉम एन टू ई, इसका प्रोजेक्शन. सो दिस dn प्लस ne, मैं लिखा dn प्लस ne इज द डिस्टेंस इन द लास्ट सेकेंड, d to n एंड देन फ्रॉम n to e. dn कितना है देखो डायग्राम में, d to n कितना, amplitude minus a sin phi. A sin phi is this distance O to d. So O to n minus O to d, that is a minus a sin phi is dn. लिखा कि नहीं मैंने, dn is a into a sin phi, a common 1 minus sin phi. Similarly ne देखो डायग्राम में आके आराम से देख लो, ne is on minus oe. on is a, oe is a phi है तो ये भी phi है. So a cos phi, a minus a cos phi is ne. मैं लिख दिया, देखो 5. So dn plus ne will be distance travel last second, last 10 to 10, t is equal to 10 to t is equal to 11 second. That's what I written. That is equal to how much? कितना रहे? दोनों का ऐड कर दो. a 2 minus sin 5 minus cos 5 है ना? So that is 2 minus sin pi by 3 minus cos pi by 3, 10. 2 minus this is cos 60 is 1 by 2. So 3 by 2 minus root 3 by 2. So that will come out with 5 into 3 minus, that is 6.34 centimeter. Okay. So total distance how much? 0 to 10 is 100 centimeter. ये मार्क कर देते हैं. ये 100 सेंटीमीटर. और इधर आ जाओ, इधर आ जाओ, इधर आ जाओ. ये है हमारा 10 to 11 is 6.34 centimeter. So total distance how much? This. Yes or no? कितना इजी हो गया रेफरेंस सर्कल से, फटाफट बन गया. कोई एक्सप्लेनेशन में थोड़ा टाइम लगा आप लोगों को, आप क्योंकि आपको समझना चाहिए. यू मस्ट अंडरस्टैंड, देन यू कैन अप्लाई. सो थोड़ा सा टाइम पहला फर्स्ट टाइम लगेगा. उसके बाद आप जैसे प्रैक्टिस करेंगे फटाफट होगा ये. इट विल बी डन वेरी वेरी इजीली एंड क्विकली. पर नेक्स्ट एग्जाम्पल जाएंगे, थोड़ा सा अच्छा एग्जाम्पल आगे जाएंगे नेक्स्ट पेज में. ये समझ में आ गया ना? समझ नहीं तो और एक बार देख लो वीडियो, और नहीं तो पूछो, कोई चिंता की बात नहीं. आई एम रेस्पॉन्सिबल फॉर माय वीडियो स्ट्रेट अवे. अभी जाएंगे नेक्स्ट पेज में, पेज 3 में. ये लो आ गया पेज 3. पेज 3 में क्या क्या दिया मैंने? सेकेंड एग्जाम्पल. टू पार्टिकल्स मूव इन SHM विथ सेम फ्रीक्वेंसी. टू पार्टिकल्स अभी सेम फ्रीक्वेंसी along the same straight line, let's say y straight line, given by y1 is equal to a sin omega t and y2 is equal to a root 3 into sin omega t plus pi by 6. इस बार में pi by 6 दिया. So find the minimum time of the from the start of the motion when the distance between them becomes maximum, and also find this maximum distance. अगर खाली डायरेक्ट SHM से शुरू करेंगे तो बड़ा मुश्किल होगा आपको डिस्टेंस निकालना दोनों के बीच में, जो कब मिनिमम होगा कब मैक्सिमम होगा, वो भी मैक्सिमम होगा तो कितना होगा. ठीक है ना? उसको सोल्यूशन कैसे करेंगे? रेफरेंस ड्रा किया फास्ट के लिए. ये फास्ट सेकेंड का ये है, ए रूट 3 उसका डायमीटर है, ए रूट 3 उसका एम्पलीट्यूड है, इसका ए रूट एम्पलीट्यूड है. सो ए को लेके एक रेफरेंस सर्कल, दैट इज सर्कल रेफरेंस सर्कल 1, and a root 3 रेडियस लेके another रेफरेंस सर्कल है ना. ये रेडियस a रूट 3 में लिखा है इसमें, ये a है and same common point along the same straight line. टू पार्ट मूविंग SHM. ये मैं और थोड़ा ये करता हूँ, the same straight line about the same mean position. ये भी लिख देता हूं. about the same mean position given by this two. One is this, the other is this. Okay. चलो अभी सेम मीन पोजीशन तो सेम सेंटर में दो कॉन्सेंट्रिक सर्कल बनाया, रेफरेंस सर्कल. तो ये है P1 डैश यूसीएम पार्टिकल, यूसीएम बड़ी 1, P2 डैश इज यूसीएम बड़ी 2. P1 इज देयर प्रोजेक्शन, दैट इज एक्चुअल SHM, दैट्स P1, P2 रेड में लिखा. तो ये कोई फेज नहीं था. दिस मस्ट बी प्योर फेज इज इक्वल टू 0 लाइन. So first one is simply omega t, so उसका phase 0 है. This is the first one, P1 dash position. P2 dash position, there is a 30 degree phase, pi by 6. So this is the P2, and then the SHM body is here P2, P1 at this mean position initially. So this is the distance between them. But what is this one? P1 dash P2 dash is the distance between UCM bodies. Just note here, if I draw the projection of P1 dash, P2 dash straight line onto the diameter, that gives you distance between the SHM bodies P1 and P2. Okay, that's the main position, main point to understand. So we draw two reference circles. P1 dash, P2 dash are the UCM bodies moving along, moving with the angular velocity omega, same omega. P2 dash O P1 dash is pi by 6. This angle is P2 dash O P1 dash. This angle is pi by 6. Initial phase of P2 dash. Initial phase of P2 also, we can call this. Okay. And since omega is constant, so P2 dash O P1 dash, that phase pi by 6. The angle between these two amplitudes, this angle will always remain same only, because this is same, this is moving is same, whatever omega, this also is same omega. So the angular separation between them will not change. Okay. Okay, you have understood this. So distance between the SHM particle P1 and P2 is the projection of, as I just explained, P1 dash P2 dash onto the diameter. Diameter कौन सा है, बड़ा वाला लेटर को लिखते हूँ, M2O N2, M1 O N1 also diameter, that is smaller circle. So what is the length of this P1 dash P2 dash? Use the triangle, cosine law of the triangle, this square plus this square minus 2a root 3 cos pi by 3 whole root over. Yes or no? So that will be a square plus 3a square minus 3a square. So that is a square root over a. So this length is a. And as it moves, as they move, the separation P1 dash P2 has any position will remain a only, because this angle is not going to change. And this length also not going to change. So this triangle remains a, this dimension of the triangle is not going to change under any circumstances. Am I clear? So I want to know the, but that is, I am not bothered about P1 dash, P2 dash, that length, that is a we found. I have been asked to find out the distance between P1, P2, the maximum distance between them. The distance in P1, P2 will be the projection of P1 dash, P2 dash onto this diameter. And that projection has to be maximized. When this P1 dash, P2 dash becomes parallel to this diameter, then that is the maximum projection length will get. So that's what exactly I wrote. So since P1 dash, P2 dash is A, this becomes an isosceles triangle. So this is 30 degrees, so this must be 30 degrees, so this must be 60 degree pi by 3. This P1 dash, P2 dash makes an angle 60 degree with phi is equal to 0 line. So now that should make a 90 degree with phi is equal to 0 line, so that will become parallel to M2O N2. So that's what I'm saying. So to make the projection of P1 dash, P2 dash on the M2O N2 line maximum, that P1 dash, P2 dash line must be parallel to M2O N2. That is P1 dash, P2 dash line must rotate by what angle? ये 60 डिग्री में है, उसको 90 डिग्री करना, so 30 डिग्री रोटेट करना. So all these two lines A and A root 3 to move 30 degree each. So A should come here, that is P1 dash should come here, P2 dash will come here, because this also moved by 30 degree, this moves by 30 degree. So this P1 dash, P2 dash also moves by 30 degree, because this triangle dimensions, triangle is fixed now. The triangle, if you rotate, all sides rotate by same angle. So this I have to make parallel, this I have to further rotate by 30 degree or pi by 6. So this has to rotate by pi by 6. So all these sides, this OP1 dash, OP2 dash, they should move by 30 degrees. So this is and I'm showing the red color, the new position of P1 dash, 30 degree after rotation of 30 degree, and OP2 dash new position is up from 30 degree from this position. Understood this? So that this P1 dash, P2 dash now has rotated 30 degrees, so that has become perpendicular to the phi is equal to 0 line, which is, that means it is parallel to diameter M2O N2. Very nice. So this will see, if this moves 30 degrees, this also moves 30 degrees, this also turns 30 degrees. So this one is pi by 3 with horizontal, that will become 90 degrees to horizontal. That means phi is equal to 0 line. Once it become 90 to horizontal, so this become parallel to the vertical diameter. ठीक है, अभी देख लो. So these are rotated anti-clockwise pi by 6, 30 degree. So the figure shows the figure. The red arrow show the new position of P1 dash, P2 dash. So therefore the time at which this happens, how much? Pi by 6, this has rotate. Omega is the angular velocity. Starting from t is equal 0, after a time of pi by 6 omega, first time become parallel. After traveling one more pi, that's 7 pi by 7, again will be parallel. Again 13 pi by 6 omega, like this. So minimum time after the start of motion is pi by 6 omega. It will become maximum separation. What is the maximum separation? Magnitude. Once it is become parallel, whatever the length, same will be the magnitude, the projection here. Yes or no? So that is the maximum separation between P1 and P2, these two SHM particles, this SHM particle P1, P2. The maximum separation will be equal to, this is P1 and P2 will be somewhere here. In this, the maximum separation will be A only. Initially the separation is A sin 60, A root 3 by 2. Now when this becomes parallel, P1 will be coming here, small a position, P2 will be coming to B position. The A small a B distance will be the small a to small b position. This is the P1 position, this is new P1 position, this is the new P2 position. So this distance is the distance maximum AB. AB is the maximum distance between two SHM bodies. That's it. And that one is simply equal to length of P1 dash, P2 dash, which is equal to A. So the maximum distance between P1, P2, AB on M2, N2 line, that is equal to P1, P2 length. So that is equal to how much? That is equal to, लिख देते हैं, that is equal to A, maximum distance. This will happen this time. In minimum, smaller, the earliest this will happen at this time. Okay. अब कोई पूछेगा मिनिमम डिस्टेंस, देन मिनिमम डिस्टेंस के लिए दिस P1, P2, this P1 dash, P2 dash should be perpendicular to this line, so that projections will be coinciding one point. That means that time P1, P2 will be meeting each other. So to make it again rotate from here pi by 3, it will pi by 3 to pi by 6 become vertical. One more 90 degree, that will become perpendicular to this M2O line, M2O line. So that is 90 plus 30, 120 degree they rotate. This will be first time it will become, the projection will become, this P1 dash, P2 dash projection will become 0 when it rotates by first 30, then one more 90. So 120 degrees, that is 2 pi by 3. That's what. So the P2, P1 dash, P2 dash line becomes perpendicular to the diameter. This will happen when the P1 dash, P2 dash line rotates by further pi by 2 angle from its parallel position. That is our parallel position rotated by pi by 3 plus pi by 2. Right? So that means how much time it will take further time? That will be pi by 2 omega, then already had taken pi by 6 omega, so add कर this 2 pi by 3 omega. ठीक है ना? 120 degree by omega. From the starting position, 120 degree. From starting position to 30 degree, it will make parallel. 90 further 90, 120 degree, that means it will become perpendicular, 2 pi by 3 omega. Then next minimum distance position, that is distance, 0 distance here, 5 pi by 3 omega. Plus one more pi you add, the next minimum distance, 8 pi by 3 omega, like this. These are the time when you get the minimum distance between P1, P2, which is 0. Okay. In this case, it is minimum distance is 0. Are you understanding? So this question, so simplified by this, so much simplification. You will see the, so this type of questions you can solve very easily using reference circle method. Distance traveled by SHM particles, the separation between the two particles moving in SHM about a common mean position with the same frequency. So all these things you can very easily calculate using the reference circle. I think all of you understood this. Second questions you see it once more. And the minimum distance I did not ask in the original question, but just add a note I added at the end. That you can yourself also visualize. Very simple, nothing. If you understood the reference circle, this is easy for you, cakewalk. Okay? So all the best for your exams. How exam going? Don't worry. Sky will not fall if you do slightly wrong. You can always improve. Okay? Be confident. You will gain a lot of confidence by going through my lectures. Read the lectures, refer it to others, subscribe if you are not, and regularly, I am regularly uploading. You also should see it regularly. And in case you can contact me, I'll give it my credentials. Thank you all. We stop here. We meet very soon with the next video. Okay? Okay? So we stop here.